times 2 to the 19th power. Oh, it does. That's not bad. 1,572,000. What would you do if you had that much money? Ooh, wow. Speaking my language, Connor. And that, why did I put dollars? I just like to get some number sense as to how big that is. That'll be about enough to put my kids through college. Barely. God.
That's now money.
Oh, that's now money. If I invested it, then it would probably be maybe 3-4 million by the time they go to college.
Oh, if you invest it, right.
Projections, if you talk to my financial people, tell me that the place I went to college will cost $115,000 a year, which is times 4, $460,000 per child. Right now I have 2. So that would be about $1 million. I better hope so. Now, your children? I don't know. By the way, that's if college keeps getting more expensive at the rate that it has been, which I really don't think will happen, because if it truly costs that much, no one can afford it. Wages are not going up as fast as college is going up. So I have a theory that like there was that housing crash, right? Why did the housing crash happen? Because people were taking out loans that they didn't have money to pay back. So, but they were able to get the loan, so people were selling their houses more expensively. Why wouldn't they? Right? So then all these loans were over distributed. We got a crash. It's pretty easy to get a college loan, right? So they're just handing out money and people are just in debt, but then their wages aren't enough to maybe pay them back. I don't know what happens if you don't, like you foreclose on a house if you don't pay back the money. You lose your house. What happens if you don't pay back the money for your education? I don't know. I wonder. I mean, what if you just didn't pay your college? I just feel like something's going to happen and this is going to burst and then things are going to have to correct themselves. Banks aren't going to hand out loans as much, so less people are going to college, so college costs are going to have to come down as a result. I don't know. I'm just hypothesizing.
There is truly no way they can enforce that.
Clearly, I stress about this and think about this a lot.
Well,
you guys, you'll get there.
If the college prices crash, that means we have a reset button.
We have 20 minutes. Okay, so now we jump to series. Now, this series formula was given last year on your Regents, but I'm pretty sure that Mrs. Zig, I didn't use it with you. You guys did, I think, everything via Sigma notation. You did? Why would you memorize it? It's given on the reference sheet. It's on the Regents reference sheet, so I don't know why you would have memorized it, but okay, so you did. But using this series formula makes questions a lot easier. And I'll show you one from the Regents that just came out that uses one of these. But anyway, find the sum of the first 18 terms. So first of all, think about the test. It's not going to tell you it's a geometric sequence. You're going to have to figure that on your own by the fact that we keep multiplying by what? Right, -4. So once you realize it's geometric versus arithmetic, you know which formula to use. So S sub 18, which is the sum through 18 terms, is the first term 2 times 1 minus the rate of -4. Be careful here with that -4 rate. To the nth power, n is 18, over 1 minus -4. Now, this I can make 1 plus 4. Why can't I here? Liam. Again, that whole PEMDAS thing. This is going to be raised to the 18th power first, which in and of itself is going to be positive. So it's going to stay 1 minus whatever 4 to the 18th power is, which I'm sure is going to be way too large. So I'm just going to type this in my calculator. Be careful. So I'll do the numerator first. 2 parentheses, 1 minus parentheses, negative 4 to the 18th power, close your parentheses. There's my numerator, divided by 5. So what does that mean? Right, negative 2 point, we'll just do 7. Negative 2.7 times 10 to the 10th power, right, which is a gigantic negative number. So we would move that decimal place over 9 units. Well, we could do that here, I think. 1, 2, 3, 4, 5, 6, 7, 8. We'll just fill with a 0 because we can't really see what it is. So that will be negative 2, 7, 4, 8, 7, 7, 9, 0, 7. We'll just fill with a 0. So that should be enough to put a lot of kids through college. Oh, it's negative. Sugar.
That's the debt.
That's the debt. Very good. The national debt. Oh boy, what is that? 2 billion. 2 billion. I think it's worse than that. A lot worse than that. Okay.
Yeah, we're in the trillions in debt.
You wonder why all these people go into debt and foreclose on houses. The country doesn't set a very good example for us. Holy crow. Talk about spending money you don't have. Bad idea. Don't spend money you don't have. I'm sure you talk about that in your credit card classes, right?
I don't have a credit card class or a credit card.
Well, when you get a credit card, don't spend money you don't have.
Yeah, I
That $100 sweatshirt's going to cost
I don't buy
$150 by the time that interest is done.
I don't buy them.
Correct. Well, right. But if you don't have the money, you're not going to pay it on time. Okay. All right.
Israel, I don't buy fashion though.
Summation notation. I equals 1 to 10. Again, we are not going to plug in 1 and 2 and 3 and 4 and add all these together. Maybe plug in the first couple to see what pattern is going on. So if you plug in a 1, what do you get? 12. If you plug in a 2, what do you get? 24. If you plug in a 3, what do you get? 48. So that should be enough for you to recognize, oh, look at that, we're multiplying by 2. So R equals 2. Yes. I was going to talk about that in a minute, and we will. So now that we realize, okay, it's a geometric sequence, the series through how many terms? 10. If you plug in a 1 through a 10, you're plugging in 10 terms. Is a sub 1 we already figured out was 12. 1 minus 2 to the 10th power, all over 1 minus 2. Jalen? What is that? Oh. I thought you were super. She's correct. 12,276. So, again, we did this yesterday. Without plugging in the terms and getting the first few, how should we know that that is just from here? Right, this is the A times B to the X format. It's exponential growth. Geometric is exponential growth. Arithmetic is linear growth. Do you follow? Yes? So linear, as we learned yesterday, if something has the mx plus b format, that's linear, and that's arithmetic. This one is exponential growth, and therefore that's geometric. So I don't know if you'll remember this, but there are lots of problems that we've seen on the Algebra 2 exams that you can do with sequences and series as a part of that chapter, or you could argue it from the exponential growth thought process. And then our last one, again, a real life concept here. Company A offers $30,000 the first year with 6% raises for the first 5 years. Company B starts you off at $35,000 the first year, but only gives you a 1% raise every year for the next 5 years. Which offer is going to be better over only the first 5 years? Which offer is going to give you cumulatively more money, right? So after 5 years, your total gain from that company, and after 5 years, your total gain from that company. So company A if we do our series through 5, what is our A sub 1? 30,000. What is our R value? No. 1.06, right? I know. So, again, this is where you got to know the difference between the chapter, because if we were using an exponential growth formula, like the 1 plus or minus R, right, raised to a power, your rate would be 0.06. Here, R isn't really your rate, it's your constant multiplier year to year. So if you multiplied 30 by 0.06, then the next year you're only making like $100. That's not what you meant. You meant 1.06. So you're making the original 30,000 plus 6% added on to that. So 1.06 to the 5th, all over 1 minus 1.06. Anybody have it already? Don't forget that 79 cents. I'll buy you a cup of coffee. No, it won't.
Where?
I know. Shoot. It'll buy you a donut? No. It'll buy you air to put in your tires at the gas station. Is that 75 cents?
No. That's like $1. It's like $1 at this point.
Company B.
The air costs money.
Who haven't I heard from today? Stephanie. What's the formula? What am I plugging in and where? Take your time. Yep. Okay, and I'll let you guys do that for me. This is right now. Oh, 144. Wrong number. Can you tell me which one this is? Anybody? Did you say 178? 178, 535.18 cents. That'll pay for your tax on a $2 coffee. How's that? All right. So so for the first 5 years, that offer B is actually a better offer, right? Okay. Question is, I'm curious, at what point, because we know from exponential growth that A will eventually pay more per year.
But we don't know that for the first 5 years. Yeah, what if their offer changes?
So let's pretend that these raises are going to happen, I think by year 5, let's look at this. Here's 30,000. By year 5, 1.06 to the 5th power. This is how much you're making in year 5 at Company A. And this is how much you're making in year 5 in Company B. So Company A is already paying a better annual salary by year 5, but the total, right, the net total is not yet made up for what it was lacking in those first few years. Does this make sense? Okay? So we know that by year 5, you're already making a better salary in Company A, but yet the grand total hasn't yet made up for it. How would you, using a calculator, figure out, without doing it manually, which year, how many years you would have to stay there for in order for Company A to overtake Company B? Graph it. Okay, so tell me what to graph. Tell me what to plug in for Company A. Very good. So we're trying to figure out what year, all divided by, I'm just going to do negative 0.06 to avoid the parentheses. Got it? And the second one, the grand total, 1 minus 1.01 to the 5th. Oh yeah. Good thing I have you auditing me. Negative 0.01. Better question. What window is going to be appropriate? How about for x's? Okay, so maybe up to, I actually think by 10 years we'll be over it, but that's okay. We'll go 15 years. How about a y? 1 million? How about, I'll do like 250. I mean, any of those would be good, but curiosity. Can't stand the suspense. And then how am I going to find? Oh. Ooh. Maybe 250 wasn't enough. How do I figure it out? Second trace, intersect? Enter, enter, enter. Year 7. So after 7, it's kind of into year 7 a little bit. So year 7, B's, if you're just going to be there for exactly 7 years, B's still a better offer. But once you go over 7 years, A is the better offer. Good stuff. How much time do we have? 5 minutes? That is not true. Just because it's fun. Oh dear. Where is it?
Yeah, exactly.
Where is it? I know you miss it. I know you miss it. Shoot, where's my... Oh, here we go. Read that. One, 3, 9, 27. What's R? And they want what would be the total. So when I teach this to my kids, I'll say, if you see the word total, you're talking about a series, not a sequence, right? You're not looking for the 20th day's contribution. You're looking for the total contributions that have been made through day 20. Yes? So this would be S sub 20. And A sub 1 would be 1 cent. 1 cent the first day. Well, it depends. I'm going to do cents as whole numbers just to make my life easier, but that is a key in this problem. So 1 cent minus, what did I say in parentheses? 1 minus 3 to the 20th power all over. Oh yeah. Sorry, I don't have the thing in front of me. It's on the reference sheet, so I don't remember it. Over 1 minus 3. So when I get this answer, this is going to give me the total number of cents. And then you're going to have to move the decimal place over twice to turn it into dollars. And it ends up being, wow. You believe that?
Okay, but by the
Triple, triple, triple.
fourth or fifth day, he deposited 6 cents, so he's depositing $1.
Wait a minute. On the 4th day, he deposited 27. So on the 5th day, 81 cents. And then, I'll do 0.81 just so it's... Then on the 6th day, $2.43. Then on the 7th day, $7 times 3. 8th day, 9th day. Correct, I know, but it just... I actually, when I started this chapter, I asked my Algebra 2 kids, if you... To be a garbage man for the day, if you got paid a penny on the first day, and 2 pennies on the second day, and 4 pennies on the third day, and it doubled every day through the month, would you take the offer? And it was a resounding no, they thought. And then when we did it out, they were like, oh. It just kind of gives you a feel for the power of